Hello everyone, this is me Mehdi Hassan. Welcome to my 11th ArcGIS tutorial. At first, let us see our today's content. Today we will learn at first find out which interpolation method is best for a particular analysis by determining RMS Euro, contour map making, and lastly we will learn zonal distributions. Let us open our ArcMap. Our ArcMap is opening. Okay, our ArcMap is open. At first, let us see what we have got in our dataset. For that, we will go to the add data. We have three shapefile and a database. We'll input our database also from here. Okay, let us see our what we got in our shapefiles. Here we can see these are some areas and these are some union names and these are some UP name. And in our Thana attribute table we got some district name. These are Burguna, Borishals, and Vola, etc. The districts of Bangladesh. And in our data set, in our database, we got the UP name and the magnesium, the percentage of finding the magnesium in those UP. So our first task is to identify which interpolation technique is better for mining or to find the minerals such as manganese in this case. For that, at first we will union or at first we will join our data union ALHQ shapefile with our database to find out the union name and the percentage of finding manganese in a one data, in a one attribute table. For that, we will go to join. From here, we will choose UP name, okay, and they will click OK. So we have just choose our uh, so we have just join our database and the union ALHQ shapefile, and now we'll go to the select by attribute, and from here we will select database manganese is not equal to null, because we have seen there is a some there are some value that is null. We have to remove this and only take these values valid rows. For that we will select by attributes and apply it. So here we can see there is 307 or 307 out of 4556 has been selected, and those field the 307 307 files are not null. These have values. So we will now we will make another shape file from here. We will go to the data and export data and give it a name, export output. Here we got our export output. And now if you go to the open attribute table, we'll see there are only 370 there are only 307 values. Those are not null. These have manganese in it, and it has UP name as well as the percentage of manganese in it. Okay, now we can simply remove this database because we don't need it again. Okay, now from here we will uh, turn off our other layers to make it more faster. These are some values we have to use for the for interpolation technique. Okay, we won't use the whole 307 point for the interpolation technique. We'll divide this and test and training points. For that, we'll need a tool that we'll find here. If you right click on here, and then here is our tool. The name of the tool is geostatistical analysis. I have brought this tool previously in my here geostatistical analysis. If you go to the drop down menu from here, we will find a option that is subset features. Here is our subset features. If you click on it, okay, now here we can see there is a input features and a output training features, and from here we will get a output test feature class, and in this field we will give the size of training feature subset. Okay, from the input features, we will select export output because we just export these points because these has some values that are not null. Okay, from here we will give a name to our training points. We'll give it training. Okay, and in the output test feature class, we will get some test features, and we have to save this from in our in our folder. Okay, let us save and give it a name. Test points. We'll to give it a valid name. Let's see, give a digit on it. Okay, now the size of the training feature subset, this is optional, and by default it is 50/50. It means the training point will be 50% and the test point will be 50%, but we need this may result in some underfitting curve or underfitting analysis. If we give 90/10 or 95/5, 95% 5% in training features and test feature accordingly, we will get some overfitting curve. So we have to always try to give it 80/20 because this is thing that this gives the most accurate output. So we'll select 80% there, and this is our training feature subset 80%, and we will select it in percentage of input. Okay, now here we don't need to set any environment. No need to set any environment. We'll click OK. It will take a while, and if you close it, we can see here is our some training point and some test point. If we change this in symbology, it will be more clear to us. Let's give the symbology. These are training features. This is the green, and let's change our test feature also. Make it red. Okay. So the green point indicates our training points, and the red points indicates our test point. We will use our training points for our further analysis in interpolation technique, various interpolation techniques, and then we will lastly compare our output with the observed value. Okay, for that first we have to go to the geoprocessing and search for a tool. From here we will after selecting the subset values of training and test point, now we will conduct our interpolation techniques. We will mainly conduct four kinds of interpolation technique, that is natural neighborhood, IDW, kriging, and lastly we will conduct SP line. For that, first we have to go to the geoprocessing here and search for a toolbox. Here we'll at first do our IDW here. Okay, in our input feature there will be our training points. In our Z value, this will be manganese because we are conducting this interpolation technique to find out the values of manganese in a thana or in district area. We will give the output cell as 50. Okay, we'll rename it as manganese LW. Okay, and now we have to select our environment in our processing extent. We select it as same as layer AOI, and in our raster analysis we will select our mask as AOI and click OK. This our environment set is done. It will take a while. IDW processing the IDW interpolation technique. Our interpolation process is almost done. Okay, our IDW is done. We'll close it, and now we'll search for our neighborhood, natural neighborhood. It is our natural neighborhood interpolation technique. We'll select it from in the input feature. We'll now select as before the training, and in the object Z value we will select manganese, and from here we'll give it a name as. Okay, and we'll set our cell size as before 50. Set our environment as before. Process extent we will go give is same as layer AOI. Okay, and in the raster analysis we'll give mask as mgidw. Our invert set is okay. Okay, and now we'll click OK. This interpolation technique will take also some times. We have to wait for it. Okay, our natural neighborhood interpolation technique is done. We'll close it. After computing the IDW and natural neighborhood interpolation technique, now we will compute another interpolation technique. This is SP line. For that, we'll go to search toolbox here and search for SP line. Here is our SP line. Input feature will again select training. In object in Z value, we will select manganese. Okay, I will give it a name. MG manganese SP line. Okay, and our output cell size will be 50 again. And here we got a weighted optional. We'll give it as before as default, and in our environment we'll set this at process extent. Here we'll set is same as layer AOI. Okay, in our raster analysis we'll give mask at AOI. Our environment is complete, and now we'll click OK. Okay, this will also take a while. We'll pause our video and wait to complete the process. Okay, our SP line interpolation technique is completed. Now we'll close it. Now I will go to our next interpolation technique. Okay, we'll go to our next interpolation technique, that is kriging. We'll search for it from here. In geoprocessing, we'll go to the search for tools, and now we'll search for kriging. This is our kriging. We'll right click on it, and in our input feature, we'll again select our training value here, and in our Z value, we'll select manganese because we are conducting this for manganese. Okay, and in our cell value we'll select 50. We'll make it simple. There are a lot of options here in our environment, and here also ordinary and universal kriging. These are some methods of kriging. We will not focus on that. We will just simply go through the process. Okay, we will give it a name, kriging. The name will be ng kriging. And now we'll go to the environment, and in our process extent we'll select as same as AOI. In our raster analysis we'll select mask as AOI. Okay, our environment set is done. We'll click OK, and it will take a while. It will take 3 to 4 minutes. We'll pause our video and wait for the completing of the process. Okay, our kriging operation is completed. We'll close it. Okay, we have successfully completed our four interpolation technique, that is kriging, SP-line, and natural neighborhood, and IDW. Now we have to use another tools, that is extract multi-values to point. We'll search for it from here. Here is our tool. In our input feature, now we have to test. For that we have to use our test subsets. From here we will select our test, and then in our input raster we'll select our four interpolation raster, that is kriging, SP line, natural neighborhood, and lastly the IDW. Okay, now we'll click OK. Okay, after extracting the multi-values to a points, if we go to the attribute table of test and test, we'll see here we'll find this is our observed value. and these are the four raster interpolation analysis that we have conducted. So now we have to minus these values from the from our observed value, and then we will identify our RMSE error, and the process that get the less RMSE error, that is the most mm, accurate process for this kind of analysis, for such as for minerals, finding the minerals. And okay, now we'll go here and select all and copy it, copy selected. Then we'll go to the Excel, open a blank workbook, paste it over here, and we'll name another column, that is difference, and one for the difference for SP and for kriging, and for neighbor, natural neighbor, and the IDW. We'll name it as difference. First we'll give kriging. Here will another difference for SP, another column for difference for NN, natural neighborhood, and lastly difference for IDW. Okay, now we'll write our formula and difference here, the observed value and the computed value of from here we'll select this minus the kriging and click enter. If we double click on it, okay, we will get the difference value here, and we'll do this process for all other three columns. Okay, we have just find out our observed value, find out a difference for kriging here, for SP line, and for natural neighborhood, and lastly for IDW. Now we'll select these four because we don't need another columns, and copy them and paste them in a new sheet for our further work, make our work more easier. We'll paste it as value. Okay, now we'll make another four column, that is for RMSC, and then for kriging, for SP line, for natural neighbor, and lastly for IDW. These are RMSC error. Okay, now okay, we have to write the formula for the RMSC error, that is equal to square root, then sum square, and we have to select the difference from here, close bracket, and divided this by count. We have to close our bracket and click enter. So this is our RMSC error value for the kriging interpolation. If we drag down it, we'll find for the SP line, natural neighborhood, and IDW also. From here we can see the RMSC error for the kriging is the less, so we can say this is the best possible interpolation technique for this kind of particular cases where we need to find any minerals. Okay, now we'll go to our further process. Now we'll see how to make a contour map. At first we have to clear our selected features. We'll search for tools from here. There's contour. Okay, as we find the most less RMSC error for the kriging, we will use our kriging for our making our contour map. From here we will select the kriging layer and contour intervals. In our environment we'll set as before, we'll set it as AOI, and in our raster analysis we'll set it as in our mask, that is AOI, and click OK. Click OK. Okay, we have to give a control interval here. This is very important to process for our further process. If we will give a control interval here is point 1, because if we see the range from here, the clicking range, and this is 0.01 to 0.06. If we give the control interval 0.1, we will get a pretty good contour map. We will give a 0.1 as control interval and click OK. Okay, our contour map is producing. Okay, our contour map is produced. If we can turn off the all other layers and only open our contour map, you can see that this is our contour map, and now we can change this symbology from here in the properties. From here in the symbology, we can categorize this with various color. If we select contour and add unique values, here is we can show this by the width of the lines, or we can show this by the color. There are several techniques we will discuss it on our further videos. Now we'll simply just produce a contour map. Okay, we have to go to the view, and from here we have to go to the layer view. Okay, we have to right click on it and zoom to layer, and give all other inputs in the here, that is map component, that is that can be a north arrow. From here a north arrow, and as it is we can see we can input the north arrow scale bar and the legends from here. It will take some time. I will show you a previously prepared map here. Okay, here is a previously prepared contour map. This is a contour map. This is also prepared from the same data. Okay, here is the insert map, and this is the north arrow. This is the scale, and there is a legend, and in the sidebar we have seen the coordinate systems. Okay, okay, we have seen our contour map making, and now we'll see our zonal statistics. For that, we have to dissolve this Thana into district. We'll go to the geoprocessing and dissolve, select our dissolve, and from here in input feature we'll give Thana, and here we'll select district name and click OK. Okay, our Thana is dissolved, and make the districts from here, and now we'll search for another tools, that is from our search for tools here, and this is our zonal statistics. Statistics, if you right click on it, from here we will select in our input feature we will select Thana dissolve that we have done lastly, and in our zone field we will select district name, input a raster value, that is kriging, we select kriging, and we want to statistics for mean value. We can select here from mean, maximum, minimum, range, standard deviation, and sum. We will select mean, and in our environment we will select as before. In our processing extent we will select as AOY, and in our raster analysis we will select as select mask as AOY. Click OK. Okay, our zonal statistics is done. Here is our zonal statistic. If you turn off all the layers and only open it, we will see this is in black and white. We can change the color from the symbology. We have discussed it way before. Okay, this shows the mean value, and we can produce a map from here by going to the view and layout view here. If we zoom to the layer, okay, we can prepare a zonal statistics map from here. So that's all for today. We have just seen in this tutorial that if we don't know which interpolation technique will work more accurately for a particular case, we'll simply run some expected interpolation techniques such as natural neighborhood IDW, kriging, SP line, etc. And from the RMSE error, we can find out which interpolation technique will suit this particular case, and then we saw how to produce a counter map, and lastly we saw how to produce a zonal statistics. So that's all for today. Thank you everyone for your patience and keep learning with me. Thank you everyone. See you later in the next video.